cascaded counter. So what is a cascaded counter? Ji beta, what is a cascaded counter? So if you see on the right hand side, so this is a cascaded counter. If you see this structure, counter structure, this is a cascaded counter. Ji beta. So in this fashion, can you see this counter, cascaded counter?
Yes.
So actually, if you see in this structure, if you see the structure, so actually, how many counters have been used in the above figure? How many counters have been used? How many counters have been used?
Two.
Two counters have been used. And what is the size of each counter?
16.
16 bits. So actually, it means that there are two counters. Each counter. Okay, so each counter can count up to 65,535. So the maximum counter. So it means in this cascaded counter. So in this cascaded counter, two 16-bit have been. If you look at the first counter, so the first counter is using clock as an input. The first counter is using clock, and the second counter is using which signal? बताएं?
आउटपुट पे है वो कह रहा है ना काउंटर 1 की.
Yes, it's the output of top. What is the name of it?
Top
Top
one.
one. Top one. So actually the top one. Okay. So when top one. Okay. So now if we say if you look at this, so when top one will be asserted, when top one will be high, when type one will be high. G. When top one will be high.
सर सेकंड काउंटर स्टार्ट हो जाएगा.
लो एज पे टॉगल होगा.
Yes. So when counter 1 will reach what? When it will reach its maximum value.
Maximum.
Okay. So what is the maximum value? So now what is the of counter 1? What is the maximum value of counter 1?
Sir 655.
35. So that's the maximum value of counter 1. So actually this is okay. The maximum value of counter 1 is 65,535 because otherwise if it is an n-bit counter, so what will be the maximum counter? 2 to the power
n minus 1.
n minus 1. Now in this case n is 1, so that's the reason. So actually if you see this, so it means that now you have a clock signal. So now you have a clock signal, so now you have a clock signal. These are two outputs, so this is a clock signal. Okay, so the clock is 1, now clock is 2, now clock is 3, now and clock is 4 now. So if we see, so now you have some count 1. So count 1, the value of count 1 is 0 at this point. The value of count is 1 at this point. The value of count is 2 at this point. The value of count is 3 at this point. Okay, and at one point, actually, so when you have the 65, when it reaches the number of clock cycles are 65,535. So at this point, count 1 will be 65,535. Am I right or not? So in this case, now initially, so we can say that initially top one is 0. Top one is 0, and it will be 0 for the whole duration. So when count 1 will reach its maximum value, what will be the value of top signal? 1?
653
No, the top one. Top
1 हो
one.
जाएगी सर.
Top one will be 1. And in the next cycle, so when you say in the next cycle, so if you see in the next cycle, the top will become 0 again. So it will again start the counter from 1 and 2 and so forth, so on. Okay, so at this point, one is 1. At this, what will be the value of count 2? Count 2. So the count 2 is 0, 0, 0, 0, 0, 0, 0, 0. And when it's done, it will count. And count 2 is now counting clock or top 1?
So top 1.
Top 1. So in this case, what will be the value of count 2? Count 2 is 0. And now count 2 will be
1.
Now it will be 1. And this will go on again. So this top one will be 0 for very long time, until and unless if the number of clock cycles that are 65,535 again, so again top one will become 1. And at that point, what will be the value of count 2? So this is a cascaded counter. So it means that the output of the first counter will be the input to the second counter. So this implies that counter 1 is counting the clock pulses. Counter 1 is counting the clock pulses. So we can say like this: counter 1 is counting. What about counter 2? Counter 2 is counting what?
Top 1.
Top 1 pulses. Now you can think it of as a clock. You can think of a clock. So in a clock, you have like a second, if you remember, a second, and then a minute indicator, and then you have an hour indicator. So let's assume that initially is 0, 0, 0, 0, and 0, 1, 0, 0. Okay. So now you will start counting the seconds. The second will go from 0, 0 to what?
59.
59. When it reaches its maximum value, so it will assert the signal top 1. Am I right or not?
Right, sir.
Top 1. So after this, 59 will become 0, 0 again. What will be the value of minute?
1.
0,
1.
1. Should be 0, 1. And again, the second, you will again counting from 0, 0, 0, 0 to 59. Again, when it reaches the maximum value, top 1 will again insert it. It will become 0, 2. Am I right or not?
Right, sir.
Okay. Now, what should we do now? It means that now the top 2 from minute 2, where should it go? Top 2. Where should top 2 go? Top 2 should
Top
go
3.
to the input of the hour. Am I right or not?
Right.
Okay. So now this is a cascaded counter in which you cascade multiple counters. Okay. So now there are two options. If you look at this structure, so actually it is a 32-bit counter. It is a 32-bit counter, and a 32-bit counter is realized by cascading. 32-bit counter is realized by cascading two 16-bit counter. It means, so we can write it like this, that a 32-bit counter is realized or implemented in simple words by cascading to okay. Why we are cascading these two counters? So actually, if you want to count for if you want to count large number of for larger timer interval, larger timer interval, larger timer interval. So then let's assume if we have a 16-bit counter. So if we have 16 and the clock frequency is 1 microsecond. Maximum range. What is the maximum range of the counter? Maximum delay it can be tracked by the counter is 65,535. Hmm? So now if you use a 32-bit counter, what is the maximum delay? So the maximum delay is okay. So now you use calculator, and we are using it in scientific 2xy 32 minus 1. This is the maximum delay. The maximum delay is 6492 micro. If we convert it into second, so what is the second? If we convert it into second, 1, 2, 3, 4, 5, 6. So 4, 9, 4, 2, 9, 4 dot audio value 9, 6, 7, 9, 6, 7, 2, 9, 5 seconds. So that's the maximum delay that you can model. बेटे समझ आ गई या नहीं आई से? Any question?
No, sir.
Okay, so that's the reason that you are cascading on. So why you are cascading these two counter? If in the market you have available a 16-bit counter and you have 16-bit counter chip, but you want to delay, you can want to model more delay. So if you want to model a bigger delay, so you can cascade them in a serial fashion, in which the output of the counter at the least significant position, that is the top signal, is given to the input of the second counter. ठीक है बेटा? अच्छा. Now, what is a prescaler? Prescaler. So prescaler, if you see it like this, now this is a prescaler figure of it. Can anybody give me an idea of a prescaler?
सर पी स्केलर वही होता है कि मतलब कि आपने एक मतलब स्केल देना है कि उसके बाद वो काउंट को मतलब कि ना कितनी पल्सेस के बाद वो काउंट करे, क्लॉक के पल्सेस के बाद काउंट करे.
ये भी बेहतर है. Actually, in a prescaler, it's a very good concept. That if you see a clock, so let's assume we have a clock. I will explain this with an example. See the clock. So now this is a clock. और आपकी बात बिल्कुल सही है. I totally agree with you. It's a very good idea. It's a clock. Now let's assume that the delay of one clock is 1 microsecond. 1 microsecond. So it is also the second delay is also 1 microsecond. And 1 microsecond. All of these delays of 1 microsecond. Okay. So now if you want to count up to smaller granularity, so it means that now the prescaler also depends upon the mode. Okay, so also depends upon the mode. Maybe the mode bit. So now we have different 4 mode bits. So the mode can be 0 0, the mode can be 0 1, the mode can be 1 0, and the mode can be 1 1. So there are different modes of a pre-scaler, and it also depends the unit. What is the unit? What is the unit of one count? So the unit of one count. So maybe when the mode is 0, 0, the unit is 1 microsecond. The unit of one count, maybe 0, 1, it is 2 microseconds. So if it is 2 microseconds, how many clock pulses is this counting? 2 clock pulses? Am I right or not?
Right, sir.
Okay. And if it is 4 microseconds, then how many clock pulses is counting?
4.
4 clock pulses. Now let's assume a scenario. That we are in mode 1. And in the last, okay, so I'm just making it like 4 microsecond, and if it's 1, 1, maybe it is 8 microsecond. 8 microsecond. Okay. So now I'm using a very smaller block. Okay, so this is the one. So now let's assume you have a mode is the mode bits of now let's assume the mode is 0, 0. So now what will be the value of count? What will be the value of count? So the count will be at this point 0. At this point it will be 1. At this point it will be 2. And at this point it will be 3. At this point it will be 4. And at this point it will be 5. And at this point it will be 6. Because the mode is now 0, 0. So now let's assume a scenario. Okay? Let's assume a scenario. This is 1, 0, 1. So now let's assume a scenario when the mode bit is 0, 1. So if the mode bit is 0, 1, if you look at the mode bits, so what is now the unit of counting? What will be the count at this point? The count will be 0. And at which point the count will be 1? जी बताया बेटा.
2 पे.
Yes, very good. So actually it will be 1 here. And when it will be 2?
4 पे.
And it will be? And similarly, if we change the mode bit, mode is equal to 1, 0. 1, 0. So you look at the mode bit, mode is 1, 0. So then what happens? Now what will be the count in this point? The count will be 0.
0.
And when it will be 1? Achha, now I have a question. If you want to delay, if you want to model a delay, if you model a delay of, if you want to model a delay of 3 micro, which counter will you use? Which mode will you use? Or 59 microsecond. Which mode will you use? जी बेटा बताएं. If you want to model a delay of 59 microsecond, which mode will you use?
सर
Which
मोड
mode
पे 9 हो जाएगा.
of
Yes.
scalar will you use? बताएं बेटा.
Sir, 59.
No, which mode will you use? Mode 0, 0, 0, 1, 1, 0 or 1, 1?
0 0 sir 0 0
Why 0, 0? Because okay, now it's very important. Because mode 0 will be used because a single unit of a single unit that you're actually measuring, a single unit that you're actually measuring, a single unit of measure is micro. In this case, when should the top signal be asserted? When should be the top signal asserted? When should the top signal should be asserted? So the top signal should be asserted. Top signal should be asserted or highlighted, or after how many counts? After 59 counts. The count reach 59. You multiply it with the clock period. It is 1 microsecond. Okay. Now, if you want to model, if you want delay of, let's assume, if you want to model a delay of 600 micro. If you want to model a delay of 600 micro. Okay, you can use both modes. You can also use mode 0, 1. You can also use mode 0, 1. So you can use mode 0, 1. So if mode 1 is used, so if mode, you can also use mode 1. If mode 0 is used, mode use 0. So when should top signal be asserted? When should top signal be asserted? So it means the top signal should be asserted. After how many counts?
6 600
600 counts. But if, okay, so if mode 1 is used, when should be the top signal should be asserted? How many counts?
300
300. It's very simple. And if mode 2 is used, after 150, am I right or not? Because the unit is, because now the unit is 150 multiplied by 4 units is equal to 600. Actually, so now we can increase the range. So it means if we can increase the range, so it means this implies that we can increase the range of the maximum range. So we can increase the maximum range, or we can increase the maximum range of the counter by higher mode. Am I right or not? Range of the counter by using a how. So let's assume we have an n bit counter. We have an n bit counter. So if we have an n bit counter, so the maximum range will be 2 raised to power n minus 1 when mode is 0, 0. Am I right?
right sir.
And when the mode is 0, 1, then when the mode is 1, what is the maximum range? 2 raised to power n minus 1 multiplied by 2 when the mode is 0, 1.
0
And what will be the maximum range? 4 when the mode is 1 0. And what about, so it will be multiplied by 8 when the range is 1. Okay, so if we increase the range, so we are decreasing the resolution. We are decreasing the resolution. So the minimum resolution, is t period. What is t period? ये बताएं. 2 multiplied by t period. What is t period?
सर टाइम पीरियड है वो
Period,
उसकी
yes. हाँ?
सर उसकी जो मतलब कि वो क्लॉक आ रही है ना उसके मतलब
Yes.
कि
So it is 4 multiplied by t period, and in the last one, the minimum resolution is 8 multiplied by t period. So the minimum resolution is, what is the minimum time interval that you can count? So the resolution is referred to as, the resolution is minimum time interval you can track with a single count. Okay, so in this case, if you look at the mode 0, so it means you are tracking 1 microsecond. So if you change the to mode 1, so the minimum resolution you are now tracking is 2 microsecond. So the 2 microsecond is for when the mode is 0 1. So it means now you are tracking 2 microsecond. Now you are tracking up to here 2 microsecond, and so forth, so on. So similarly, if you want to highlight if the mode is 1 0, so you are tracking 4 clock cycle, 1 2 3 4. So it means for 4, this is 4, and then you are again 4, so which is 4 microsecond, 4 microsecond, not 4 microsecond, but 4 multiplied by pt period. So it means it actually is not 4 microsecond, but it is 4 multiplied by t period, and t period may vary. It depends on the clock frequency. So if the frequency is f, so if the frequency of clock frequency is f, so what is t period? So t period is actually, t period is equal to 1 divided by f, and f is referred to as the clock frequency. ठीक है बेटा, समझ आ गई या नहीं आई? ठीक है. So the prescaler divides the clock. It divides the clock. It divides the clock, and it increases the range and decreases the resolution. So what is a clock divider? What is a clock divider? बताएं बेटा, बता सकते हैं what is a clock divider? Prescaler divide the clock. Prescaler. Can you let me know what is a clock divider? G, anybody?
क्लॉक को डिवाइड करता होगा लाइक इसी तरह ही होगा.
So now let's assume it's a clock. Okay, so it's a clock, and if we want to divide the clock, so it means if we want to divide the clock, so we are reducing the frequency of the clock. We are reducing the increasing. So dividing the clock means, dividing the clock means if you reduce the frequency, so what does it imply? Increase what? Increase the clock period.
टाइम
It's increase the clock period, yes, in the time. So it means the clock. So if we say that we have now clock by 2, so it means that we have reduced the frequency by 2. So now the clock has high time here and low time here. High time here and low time here. High time here and low time here. High time here and low time. समझ आ रही है बेटा? Now,
Yes,
if
sir.
you if you see, so if let's assume if the delay is 1 microsecond, so 1 microsecond, it's the clock period, 1 microsecond. So if you look at the lowest clock, so this delay will be, what will be this delay?
2 microseconds.
2 microseconds. And what will be this delay?
2 microseconds.
Okay, now in the above example of a clock, what is mode now in this case? Mode is what?
0 0.
0 0. In the second example, what is mode?
0 1.
0 1. Very good. Now, proceeding or moving out further, if we say, if we moving further, if we want to divide this clock by, 4, clock by 4, so how will it look like? It will look like this. Am I right or not?
Right.
Now, what is the duration of this?
4 microseconds.
4 sec.
4 microseconds. Yes. And what will be the mode now?
1 0.
So can we draw it like this? Now, if you look at the figure, this, can you see the figure? Please scale the figure above. So now you have a clock. So can we use a multiplexer here? So it means now we are using a multiplexer here. Can we use a multiplexer here? We are using a multiplexer. The input to this multiplexer is clock. The input to this multiplexer is clock divided by 2. The input to this multiplexer is clock divided by 4. And the input to this multiplexer is clock divided by 8. What is clock? Clock is coming from here. So this is clock here. It's coming here. And then clock by 2 is coming from here. Note about clock by 8 is coming from here. Clock by 4, sorry. And now you have mode bits. So now you have mode bits. So the mode bits are 2 bits. So mode bits. So if the mode bit is 0 0, the mode bit can be 0 1. The mode bit can be 1 0. The mode bit can be 1 1. And the output of this multiplexer. So now we have the output of this multiplexer. So the output of this multiplexer. So you can have multiplexer will go to the counter. And it will give the counter as a counts and the top signal. What is the count bit? Count is actually n bit. And the top signal will be inserted when it reaches the maximum value. So actually, if the mode bit is 0 0, so it implies that if the mode bit is 0 0, so it will be count the pulses of clock. And in this example, it is 1 microsecond. If the mode bit is 0 1, it will count the pulses of clock 2. And in this example, it is 2 microseconds. And if the mode bit is 1 0, it will count the pulses of clock divided by 4. And in this example, it is 4 microseconds. जी बेटा समझ आ गई या नहीं समझ आई?
Clear है sir.
ठीक है, very good. So now we proceed further. So it means that the prescaler can be used to divide the clock. We can divide the clock by 2, by 4, and by 8, and it's a multiple of 2. It increases the range. But it decreases the resolution. Resolution is the minimum interval that you can count. So if you increases the range, the resolution will be reduced. The minimum counted will be reduced. Okay? Now, what is the reaction timer? What's the reaction timer? So it's I'm just reading this, that it measures the time between turning light on and user presses button. Okay, and there is some indicator like, so it's just like a stopwatch. In stopwatch you have a stop, and then you have start on. And then, so actually when you can reset the counter, so when you reset the counter, it's just like your turning light. the light on. Okay? So when you reset it, it start counting. It start counting. Reset and you start the counter, so it start counting. And when you push the stop button, so actually at that point it will stop counting. So reaction counter a timer is just think the reaction counter as a stop watch. ठीक है बेटा? What's the watchdog timer? G. It's very important concept. What's a watchdog timer? G. Anybody? बताएं बेटा, आप लोग सारे रिस्पॉन्ड नहीं कर रहे.
यस सर, सर नहीं पता है इसका वाट्सएप टाइम.
कुछ पढ़ के बता देना कि क्या चीज है ना. अब देखें यहाँ पे लिखा हुआ है ना, इट मस्ट
सर ये रिसेट भी कर देता है.
तो रिसेट व्हाई शुड वी रिसेट?
सर ये फेलियर डिटेक्शन के लिए होता है.
हाउ फेलियर कैन बी डिटेक्टेड? हाउ फेलियर?
सर जब सर ये लाइक क्लॉक सिग्नल्स को क्लॉक अपना सिंक में रखता है, अगर वो उसको सिंक में नहीं मिलता होगा तो वो रिसेट कर देता है क्लॉक.
Why? What's the reason of this reset?
सर एरर डिटेक्ट करता है ना तब.
Very good. It detects the error. Why an error should be detected?
सर क्योंकि अगर क्लॉक खराब हो गई तो हमारा वो लाइक इनपुट्स आउटपुट वो सिंक में नहीं रहेंगे.
No, actually, watchdog timer is like, let's assume it is used in the scenario. Watchdog timer. Watchdog timer is used in a scenario. Timer is when people using any machine, and they some people in common people are using it. Some people may not actually use the machine. They don't know how to operate the machine. So it's possible. Now let's assume there is an ATM in the bank. Okay, so when you go to an ATM machine, maybe you correctly use the machine, you insert your ATM card, and then you pick out some money. But maybe there are some users who are not able to use the machine. In this scenario, the watchdog timer is used. Now let's assume a scenario. And even somebody is using the machine correctly and he forgets something. Let's assume a scenario. Now I'm highlighting a scenario. You insert your card. And the system expects some input from you within 1 minute, maybe within 1 minute, and you don't give any input. What should the system do in this scenario? Give it up.
Transaction cancel.
Yes, the transaction should be cancelled. The machine should not take the card for a longer interval. Otherwise, it will not be able to service another user. So it should cancel the transaction. And if it should cancel the transaction, what should it do now? If it cancel, it should give the card back. Am I right or not? Am I right or not?
Yes, sir.
You should give the card back. And let's if it give back the card, okay, and the user is not like collecting the card, so it means something maybe bad is happening. Maybe the user has left the ATM machine. What should now the ATM machine? What should now the ATM machine do? Me as a designer. It's a very simple question. It's not a technical question. Let's assume that the user has inserted a card scenario, the user has inserted a card and he's not given any input. So it means after maybe some time interval, the system will give the card back to the user. And the user has not picked up the card. What should the system do? The system should pull the card back and store it with itself. समझ आई बात या नहीं? अगर 2 मिनट के बाद. So you can also use a watchdog timer in that scenario. So what's the, it should reset the timer every X time units, else the timer generates a signal. And it is used to detect failure as self resets. Okay, so that's the advantage of a watchdog timer. So actually you can in the ATM machine, so you can say for just take for ATM example. Okay, so when the user inserts the card, system generate a timer, and if the user does not give any input specified interval, maybe 15 seconds, maybe 1 minute, then the transaction cancelled after interval, and the system should reset itself to the initial state. So what is an initial state? Just should reset it. Okay, okay, so the transition should cancel and the system should shift to initial state, or system should ask the user to take the card. No, another scenario, if the user does not take the card, so then again watchdog timer, again watchdog timer initiated, and after maybe and should drop back the card if the user does not collect it. If the user does not collect it, and the system should be initialized to initial state. ठीक है बेटा, समझ आ गई? Any question? आवाज नहीं आ रही बेटा?
हाँ सर, आ गई समझ।
आ गई? So actually it can be used to detect something, and you can see the details in the book. So these watchdog timer, you can see the details. Okay, now we will study pulse width modulator. What is a pulse width modulator? जी बताएं बेटा.
सर पल्स की वो लेंथ इंक्रीज या डिक्रीज कर देता है।
Very good. You can increase the length of the. You can increase or decrease the length. What is the advantage of this pulse width modulator? जी बताएं.
सर जैसे हम एलईडी ब्लिंकिंग में हमने स्पीड सेट करनी होती है कि किस मतलब रेट पे ब्लिंक करे, उसमें यूज हो सकता है।
Why it's like this? Why should it be like this? Why? So the pulse width modulator generate pulses with specific high load times. So if you look at this example, so in this example, what is the high time of this signal? And what is the low time? So it's the high time and it's the low time. So what is it now the duty cycle?
Sir, 80%.
Why it is high time?
20%.
सर
25%.
20% मिलेगा ना कि वो कितने टाइम हाई रहती है
Duty cycle is equal to high time divided by high time plus low time. High time plus low time. Duty cycle is equal to high time divided by high time plus low time. So if you look at this high time, how many clock pulses are there in the high time? 1 and 2 pulses. And how many pulses are there in the low time? 6 pulses. 1, 2, 3, 4, 5, 6. So now what is the duty cycle? High time is for 2 cycles.
2 और 8
2 plus 6. And it's also multiplied by 100. We also multiply it by 100 because we have to take in 100. So multiply by 100. So this is equal to 25%. So this in this particular example, the duty cycle is 25%. Okay. Now you have a square wave. Now a typical clock is a square wave. A typical clock is square wave. So it's a square. So the high time is equal to the low time. So in this example, so the PWM signal, so this is the high time. How many clock pulses are there during the high time? So now this is in the second example. So you have high time, and low time, they are equal. Low time are equal. So this is also 4 clock pulses and 4 clock pulses. It means it's 4 divided by 4 plus 4 multiplied by 100 is equal to 50. So it means that the duty cycle is equal to duty cycle is equal to duty cycle is equal to, so if both are equal, so if it is equal, so you can write it like this: high time divided by high time, because high time is equal to low time, it's also ht, multiplied by 100. So can we write like this: ht divided by 2ht multiplied by 100. ht and ht will cancel out, and now it is 50%. So the duty cycle will be 50% when the high time and the low time is equal. Now in the case of 75% duty cycle, so 75% duty cycle, 35% duty cycle. So in the high time, so what is now the high time? So the high time is now, the high time is 6 clock pulses and the low time is 2 clock pulses. The duty cycle is now 75%. Okay, why we are using PWM signal? Why we are using a PWM signal? So now if you look at the objective, so now we are controlling the voltage. We are controlling the voltage using duty cycle. So if you look at this example, so for a 25% duty cycle, so if you see this, for a 25% duty cycle, in the above table for a 20. So if the duty cycle is 25%, what is the corresponding voltage? If you look at the above, what is the voltage? 1.25 volt. If the duty cycle is 50%, what is the voltage? 2.5 volt. And if the duty cycle is 75%, what is the corresponding voltage? 3.75 volt. And the duty cycle is 100%, like high, it's always high, 100%. So maybe in 100%, you have 5 volt. So why we are using PWM? So it means why we are using PWM signal? Why not directly 1.25 volt and 2.5 volt and 3.75 volt or 5 volt directly? जी बताएं बेटा. Abdullah. Abdullah.
Yes, sir.
Why we are using PWM signal? Because the PWM signal can be used to control average voltage to drive an electric motor. जी बताएं why? So actually, no idea. Okay. Now let's assume that if you are using a microcontroller, let's assume you are using a microcontroller. Can a microcontroller operate on different voltages or is operate on a single voltage? ये बताएं बेटा.
डिफरेंट वोल्टेज पे कर सकते हैं ना.
क्या कर सकते बताएं बेटा.
डिफरेंट वोल्टेज पे ऑपरेट करता है.
Different. It operates on different voltage, but it only generates either a logical 1 or a logical 0. Am I right or not? It only operates on logical 1 or logical 0. It's not an analog device. In analog, actually, if you look at this value, it only operates on single voltage. If you look at this, there are different ranges of the voltage range. Voltage range 1, voltage range 2, voltage range 3, and okay. So now why it is? So it means that let's assume you are using one motor. You are using a motor. You are using a motor. So if the voltage is 1.25 volt, so the speed should be low or high?
Low.
Low. And what about this? In this case, the speed should be low or medium?
Sir, higher than 1.25.
It means let's say medium.
Yes.
And in the last case, it is highest speed. Am I right or not?
Yes.
If you want to control the speed of a motor through a microcontroller, but microcontroller cannot control voltages, cannot generate voltages out of the signal. So what you do that you actually, and microcontroller can only generate. So microcontroller, now you have microcontroller. So microcontroller generate a PWM signal. It can generate PWM signal of 25% or 50% or 75% or 100% to control a motor. समझ आई बात या नहीं आई? ठीक है. And it can also, you can also have the lower speed, or we can also, it can also be used, it can have, we can also have different scenario. In this case, it is a dim light, and in this scenario, light should be dim or bright. Okay, so the common use, it is to control the average voltage to electric drive. It is simple to DC converter and or DC to analog converter, and DC motor speed at dimmer light, and other uses to encode the command receiver uses. So you can study these things from your book. So controlling a DC motor, so now you have DC motor, and now in this case, if the maximum voltage applied, so if it is 0, what is RPM? What is RPM? What is RPM?
Rounds per minute.
Revolution per minute, yes. Round per minute or revolution per minute. So if you look at this, you have now an RPM. Okay. So now if you look at it, so now it's yeah, again. Now this is a system design. Okay. Now you have a system design. So now this system design. So this is the system design. This signal is coming from the processor. This signal is coming from the processor. This signal is coming from the processor. Okay. And this signal is coming, this is a PWM signal. So if it is 25%, 25%, ठीक है? So it can be 0. The RPM will be 0. So if it is 0, it can be 0. It means it's always low. It is always low. If it is 2.5 volt, so what is the maximum voltage applied? Percent of maximum voltage applied? 50%. So the RPM is now 1840. So what is the reduced cycle now? 50%. In this case, the reduced cycle is 75%. So the RPM is now 6900. And if it is 100%, so it is 9200. So you can control the speed of the motor by varying the width of the PWM signal. Okay? So this is the way that how you control the speed of the motor. बेटा समझ आ गई या नहीं? Any question? Any question?
हाँ सर।
ठीक है? So in the tomorrow we will also have a class tomorrow. ठीक है? So actually and then I will upload